Okay, so the unit circle is a circle with a radius of 1. Like, whoa, we need a pen. Okay, so 1 unit, 1 unit, 1 unit, 1 unit. So it has a radius of 1. Okay, and the reason why we really like the unit circle, the equation for the unit circle is x squared plus y squared is equal to 1 squared, which is 1. The cool thing about the unit circle is that any point on the unit circle, so if I have an angle like this, theta, then this x comma y point on the unit circle, we're moving over x and down y to get to the point. This is equal to the cosine of the angle, this angle, theta, comma, the sine of the angle. So cosine is x and sine is the y value of the point. All right, so sine, like I said, is the y value, so it'd be y over 1. Cosine is x over 1. The tangent is rise over run. So let's draw another example in the first quadrant, because that makes the most sense. Y, x, and 1. So tangent is rise over run, so y over x. And because of excluded values, x cannot equal 0. The cosecant would be the reciprocal of sine. So we get 1 over y, where y cannot equal 0. Again, cosine and secant are reciprocal, so this would be x. This would be 1 over x, where x cannot equal 0. And cotangent and tangent are reciprocals, so x over y, or y, cannot equal 0. When y equals 0 or x equals 0 on these functions, we get vertical asymptotes on the graph. All right, we're going to sketch the graph of pi over 6. Okay, so pi over 6 is closest to the x-axis. It is technically 30 degrees. So I'm going to put my theta in here as pi over 6. Because I remember about 30, 60, 90 triangle rules, across from 30 is the smallest side, so 1/2. Across from the biggest angle, that's not 90, would be root 3 over 2. And across from my 90 degrees is a 1. So the sine of pi over 6, that would just be my x, or my y, 1/2. Technically, it's over 1 for the radius, so the y over the radius, which is just 1/2. So we can see that the sine, when our radius is 1, the sine ratio is just the y value. Okay, so the cosine of pi over 6 is is x over 1. Our x value is root 3 over 2. Tangent is a little trickier. It's y over x, so we get 1/2 divided by root 3 over 2. How do we divide fractions? We multiply by the reciprocal. So I'm going to go ahead and do that. Multiply by the recips, giving us that cancels to make a 1, that cancels to make a 1. 2 divided by 2 is 1, so get 1 over the square root of 3. Y'all know that we need to rationalize, so I'm going to go ahead and multiply by the root 3 on the top of the bottom, giving us root 3 over 3. So that's a common ratio, that's a common ratio, that's a common ratio. Know them, learn them, love them. Okay, cosecant is, it's the reciprocal of sine. So once you get choices, you can either say it's 1 over my y value. So 1 over the y value is 1/2. Again, multiplied by the reciprocal, giving us 2. The other thing you can do is just look at the sine ratio we already figured out and take the reciprocal. Okay, so we'll do that for the next one. Secant is the reciprocal of cosine, so I know root 3 over 2 is cosine, so cosecant would be 2 over the square root of 3, but we got to rationalize, giving us 2 root 3 over 3. Again, pretty common ratio for us here. So cotangent of pi over 6 is the reciprocal of what? It's the reciprocal of tangent. Knowing that, well, really this 1 over root 3 is the tangent ratio. So I'm going to go ahead and reciprocate that so that my root doesn't end up in the denominator. So the reciprocal of cotangent would be root 3 over 1, which is just the square root of 3. Okay. All right, let's look at the next ones here. We're going to look at the unit circle. You should have already filled one of these in during class. So if I have a 45, 45, 90 triangle, 45, 45, 90, or pi over 4, pi over 4, pi over 2 triangle, we're going to go ahead and look at, we know the rule is x, x, and x square root 2. So, okay, so if we make our radius equal to 1, then 1 is equal to the length of our hypotenuse, which is x root 2. So x is equal to 1 over the square root of 2, which again we rationalize, which is root 2 over 2. So x is equal to root 2 over 2 and root 2 over 2 when our radius is equal to 1. A 30, 60, 90 triangle. We have 60, 30, and 90, or pi over 6, pi over 3, and pi over 2. The rules for those are x is the short side, 2x is the long side, is the hypotenuse, and x root 3 is the side across from 60. So again, let's make our hypotenuse equal to 1, or our value equal to 1. So that means that x is going to equal 1/2, and then x root 3 is going to equal 1/2 root 3, which we call root 3 over 2. So we use these ratios when we write in the coordinates in our unit circle. Okay, so let's go ahead and look at the first quadrant of our unit circle. We know that each one of these angles in radians is going to, first we have pi over 6 because it's closest to the x-axis, pi over 4 is the middle whisker, and pi over 3 is the biggest wedge. Okay, this one is pi over 2, and now we're moving in the second quadrant, so we're going to go pi over 3, pi over 4, pi over 6, and then pi. So we're one wedge, so we're only on 2 wedges of the 3. We've only gone 3 of the 4 and 5 of the 6. We talked about this in class. Okay, again, 1 extra wedge, so 7 pi over 6. We have over 4, so this is 5 pi over 4, and over 3. So 4 pi over 3, and then we get 3 pi over 2. Lastly, we have over 3, over 4, over 6, and 0 pi or 2 pi. All right, so we have 12, so double the 6 minus 1 gives us 11, double the 4 minus 1 gives us the 7, and double 3 minus 1 gives us 5 pi over 3. Okay, we're going to talk about really quick about how to get the coordinates. So this right here is a 30 degrees or pi over 6 triangle. So the side length here would be 1/2, and across from that would be root 3 over 2 on a radius of 1. So my x value is root 3 over 2. My y value to get to this point is 1/2. half. The next one is our 45, 45, 90 triangle. So I'm just going to erase these. Okay, so we're going to go here, here, here. We want to get the coordinate of this point. So how far over did we move? Well, if this is a 45-degree triangle, then this would end with a radius of 1. Then I moved over root 2 over 2 and up root 2 over 2. So root 2 over 2 over 2. All right, our last part would be, oops, I was erasing. All right, our last part is, let's ooh, that's not a pretty color. Wow. Sure. Okay, that's almost what I had before. Anyway, okay, so this is a 60-degree angle. So across from 60 would be root 3 over 2. And then across from 30 is 1/2, and our radius is 1. So my x value is 1/2, and our radius is our y value is root 3 over 2. This part, when I just move upward, my x value is 0, my y value is 1. When I just at 0, my x value is 1, my y value is 0. Okay. My x value is -1 and 0 at pi. My y value is 0, -1. So something to remember about the unit circle is that, so when my angle is, let's use this angle 60 degrees or pi over 3. So the cosine of pi over 3 will equal the x value of the coordinate. So it will equal 1/2. The sine of pi over 3 will equal the y value of the coordinate, which is root 3 over 2. All right, we're going to take a little pause, and I'm going to give you a unit circle in your notes. Okay, check out this fresh, beautiful unit circle. Okay, anything that divides by 6 has the same coordinates. It's just a different x, and the signs of the x and the y values are different depending on what coordinate they're in, or quadrant. Okay, so they're all the same. The pi over 4s all have the same coordinates because they derive from the same triangle. Same with the pi over 3s. Okay, so they all kind of use the same first quadrant triangles to figure out the coordinates for the rest of the circle. All right, next up, we're going to evaluate again at pi over 3 pi over 4. So 3 pi over 4, I'm going to look at where that is. That is in the second quadrant, so almost to pi over just pi. The triangle would be, the angle is here. Theta is equal to 3 pi over 4. I'm going to use a reference triangle of pi over 4, so for my first quadrant. So I know the side lengths are root 2 over 2 and root 2 over 2, but I'm moving to the left in the x, so it is a negative root 2 over 2. So my x is negative root 2 over 2, my y is root 2 over 2. So the sine of 3 pi over 4 is just the y value, root 2 over 2. Oh, my radius is 1. Okay. The cosine of 3 pi over 4 would be root 2 over 2, but to the left, so it's going to be negative. The tangent would be these two divided, so root 2 over 2 divided by negative root 2 over 2. So that would be -1. And this is 3 pi over 4. The cosecant of 3 pi over 4 reciprocate sine. So 2 over square root of 2 Go ahead and rationalize. Is 2 root 2 over 2. Cancels to give me just root 2. Luckily, secant is the same, so this is going to be root 2. Cotangent is the reciprocal of negative 1, and the reciprocal of negative 1 is negative 1. All right, so